Hello and welcome to this spreadsheet tutorial. This is the first of 4 tutorials that demonstrate how this CRRM calculator spreadsheet works. In this first tutorial we will be concentrating on the first tab at the bottom here called CRRM calculator. This calculates the cumulative required revenue multiple, or CRRM, that is the multiple of the R&D spend that we need to get returned by way of cumulative revenue in order to reach or attain the business goals that we have set, where those business goals are set by declaring how much we're prepared to spend on R&D as a percent of revenue, what our compound annual growth rate target is, and given the lifespan of the product or projects that we use as vehicles to invest in. In this case, notice that we have set the R&D spend rate to 17%, the CAGR to 10%, and the lifespan of the projects in question we are estimating to have lifespans of 4 years. For those of you who have read the book, you will know that we are also capable of solving for the CRRM through use of a formula. And let's quickly look at that formula. That formula says the CRRM is equal to the reciprocal of the spend rate, and then there's this summation term here which includes CAGR, or the compound annual growth rate, and also the function F1, F2, Fn, which represent the annual percentage of the cumulative revenue that will be returned in each year after the investment. So that's the basic formula, and up here we use that formula to calculate the CRRM, calculated to be 6.9 because we have entered 17% spend rate, 10% CAGR and 4, and that is what it has calculated. Notice down here we're also going to, for the rest of this spreadsheet, use an iterative methodology to calculate that same number, because that was the methodology we first of all used before we had an equation, and it was this preceded the equation, so to speak. But the advantage of doing it iteratively is that we have to build up a picture of annualized revenue and how much we're spending on R&D each year, and that gives us a very good graphical picture of what the solution looks like, and we will come to that in our second tutorial looking at images of CRRM, the second tab. But for now, let's concentrate on this first tab here. Notice that the solution down here of 6.99 is exactly the same. So in other words, this has been fully solved, and let's look at the basic structure of the spreadsheet. These years here go out from 1 all the way to 50 years across, and it shows us, this is the new products section here, and it shows us both the cumulative revenue of individual crops, of annual crops of products, and it shows us the annual revenue of those. We're only showing the first 3 here, but by expanding using this plus sign here, there are actually 50 years of crops of products being produced are actually shown below that, but we have, for the purpose of looking at it on a screen, only showing 3. So this is the revenue that we're going to get from new products, and also down here is the base business. Notice that in year 0, or at the end of year 0, we normalize that base business. That is the existing business we've got from whatever products we have produced up to now. We normalize that revenue to being $100, or maybe you can imagine that as $100 million or whatever. But that base business, left to its own devices without any further new products, will naturally decline. In this scenario, we're considering that that base business is exclusively made up of products that have a 4-year lifespan. And therefore, we're trying to calculate how much that would decline, or how quickly that would decline. And notice here that approximately 90%, 88.4% of that revenue is gone by year 4. It is down to 11.6 million of revenue, and then it decreases further beyond that, but it's essentially fully depleted by year 8. We will come back to show later on exactly how that decline rate is calculated. But in this example here, our base business in year 1 has dropped to 94.9, but we're saying we'd like to grow at a 10% CAGR. So if we start started with 100 million of revenue here. By the end of the first year, we need to achieve 110 million of revenue, which is a 10% CAGR. And by the end of the second year, that would need to go up to 121, etc. across here to get to a 10% CAGR. This is fully solved, so notice that it is a 10% CAGR we're achieving each year, and we are also spending precisely 17% of revenue on R&D. So let's see what we are spending on R&D. That is the output from this solver up here, and it says we're spending 18.7 in the first year, which is precisely 17% of 110. In the second year we spend 20.6. Remember, we've grown our revenue by 10%, and therefore 17% of 121 million is 20.6. So this is the amount of money that we spend each year on R&D. Now it needs to calculate, well, here is the first crop of products that we produce, spending that 18.7 million. And it needs to calculate, what does that CRRM, what does the multiple of that 18.7 need to be in terms of cumulative revenue in order to give us 15.1 million of revenue that comes from that first crop, that adds to the 94.9 to give us the 110. And it says that that multiple needs to be 6.99. So if you notice that this first crop of products here ultimately goes on to achieve cumulative revenue of 130.7, which is precisely 6.99 times the 18.7. And in keeping with our S-curve formula, which is shown up here, which says what percentage of that revenue we would anticipate receiving each year, 11.5 by the first year, 42, etc., 90% by the fourth year, which is the definition of our lifespan, the time taken to get to 90% of the cumulative revenue. And so therefore we achieve 15.1 million of the 30.7, in other words 11.5% of that in the first year, 55, etc. each one of the years. In year 2 we spent 20.6 million. That ultimately goes on to achieve 143 million of cumulative revenue, which is 6.99 times the 20.6, etc. So as we introduce each successive crop of products here, this is the cumulative revenues they achieve. Below that we show the annualized revenue that they achieve, just simply subtracting the cumulative from the prior year. But notice that the equation is fully solved. So now let's change one of these parameters and do a new solve. In this case I'm going to just change the lifespan to 16 years, and I'm going to leave the business goals of 17% spend rate and 10% CAGR exactly the same. Immediately when I change that to 16 years, notice that this line changes here. It says if I've got a product that has a 16-year lifespan, it's going to take 16 years before I get to 90% of the cumulative revenue, or approximately 90% of that cumulative revenue. Now the CRRM calculated from the equation says the multiple needs to be 12.29, but this is still showing the old multiple of 6.9. And you can see down here that the equation is clearly not solved at this point. We're not achieving a CAGR of 10%, nor are we spending precisely 17% of revenue in R&D, because clearly this 6.99 is incorrect. So we solve for that by hitting Data, the Data tab, and assuming that you have the solver add-in in Excel, we now click Solver, and up come these solver parameters. These are the solver parameters that we have set. It says by changing certain variable cells, but also subject to certain constraints. The variable cells we would like to change, which are basically the output of the solver, are first of all the cells C10 through AZ10, that being the amount of money we're prepared to spend each year on R&D. So these cells are shown in green because they're the output of the solver. But we're saying we'd also like to change cell C5. C5 is the CRRM, so we're saying please find an appropriate CRRM that matches these constraints. And if we look at the constraints, we're saying those are cells C126 through AZ126, which is the R&D spend rate here. We want that to be equal to C1, which is the target R&D spend rate of 17%, and also cells I125, which is the CAGR. We want that to be equal to C2, which is the compound annual growth rate. So let's go and hit solve. It's now going to try to do an iterative solve for us, and you can see down at the bottom left here that it's going through various trial solutions trying to find a satisfactory answer, which it has found, it tells us. Click OK, and notice that the solution it found was 12.29, identical to what we were able to calculate using our equation. And now notice what has happened in the spreadsheet. Let's quickly go down to the end result. Notice that we have grown at exactly 10% each year, that we have spent precisely 17% of revenue. But now, because these are projects with a 16-year lifespan, notice what happens with the base business. Instead of immediately declining, that base business actually grows for a few years. That's because they are 16-year lifespan products, much longer than the 4-year lifespan products. But having grown a little bit in a few years, it then starts its ultimate decline, and by the 16th year it's at approximately 84.3% depleted. But it takes a long time for that 100 million of base business, which is now assumed to be made up of products that have a 16-year lifespan, it takes a lot longer for that base to go away. So given that our base business in year one is now 108.3, in order to reach 110 million of revenue here, which is the 10% CAGR, we really only needed 1.8 million of new revenue from new products. And we got that from the first crop of products up here. Those first crop of products, however, according to the calculation, need to get to 12.299 times what it was we spent on R&D, that being 18.7. And if I scroll over further here, you will see that the cumulative revenue that this ultimately achieves here is approximately 229.2, which is precisely 12.29 times that 18.7. And in the next year, it's 12.29 times whatever it was we spent in the second year, etc., all the way down through the various crops of subsequent products that get produced. So that multiple of 12.29 here, we can clearly see does solve this equation, in that it is now giving us precisely 10% CAGR for a 17% spend rate. So that verifies that the iterative method of solving this here works per the equation.